Hi everyone, welcome back to the channel. So this time we are going to turn our noise field particle into a curve. So first we will rearrange the index and turn it into a curve, and then we will have some technique that we can do with this curve, such as using different pattern to drive the noise, so it will not look only like a noise but also looks more like a crystal. And then we will talk about how to work this curve on any kind of geometry that you import. So that's what we will talk about in this video. But as you see in the opening animation, we have these beautiful cloth-like things. That is a beautiful accident that I discovered during the process. I will talk about this in future video, how to use geometry node to make a cloth but without any simulation. I'm still developing this, so as always, the file will be on my Patreon. Hope you can join that and get the file. So let's get started. So here is where we left last time. We have this beautiful sphere on the noise field. Let's play this again. So that's where we left. This time we turn this to be a curve. Now it's all like separate. They looks like a string, but actually they are not. So that's this node. If you didn't watch that, I suggest you go back and come back to watch through this video. So now we turn off this display point. Now we have all these points and we want to connect them together to make a curve using geometry node. So let's use a blend and maybe just name this to be display curve, and we make a geometry node for that. Okay, so now we use this to make curve connecting all these dots. Drag this master in because it got the point data. Set this to be relative. We use a curve line to resample it. Resample curve and also set position. Maybe a curve to mesh, curve circle. So that's what we're going to use. First, we connect this curve line to the sample curve and also set position. Like this first. Okay, so now we have this one curve. Now we need to use this set position to get the position from this point. So let's use a sample index. This to here, set this to be vector, and use the position and also index. So now you see this curve is being twisted. Let's try to give more sample count. You see it's all connect the dot domain size to get how many points we have. So that's what we got for this curve. Take a look at this. It looks like this, but it's not what we expect, like each string. So now let's go to the frame 0 and let's play it frame by frame. That's frame 1. That's only one loop for the point. Frame 2. Now we have another loop. Let's go frame 3. Okay, now we see what is the problem. Let's give a last point so we can see it more clear. Set this to be 10. So now we see this problem. The point is being connected like a index 0 to index 9, and here is index 10, and here is like a 19, 20, 29, and so on and so forth. That is not what we want. Actually, what we want is it connect like this instead of this. We need to rearrange or remap index, and it's a very difficult job for me because I'm not good at math. I have to roll this each index and I try to connect them, like figured out how to spend like 3 days looking at this number. I finally got it. Each loop have 10 points and we give a 3 loop as an example. The index will be from 0 to 29. So that is the number. That is the 0 and 1, 2, 3, 4, all the way to 9. Here it's 10 and 19. You see here is 0 and here is 10. And we want to connect 0 to 10 and 10 to 20. So the number we want to remap should be like a 0 to 10. And here is 20 20. Okay, so now it's one string. And then the next one we want to map is from here. So it's like 1 and 11, 21. That is another set, like a 2 to 12 and 22, 3, 13, 23. So we have to see this for how many steps we go. For that, as a one round, remap the number, something like this. So we start to see some pattern. Here it all starts with 0, and here it starts with 1, and here it starts with 2 and 3 and 4. This area, this. And how about this area? It all go like a 1, 2, 3, 1, 2, 3. Which is kind of like we use this and combine with this, we will get what we want. So that's my process. Let's see how to do it in geometry now, how to do this math. So here is like the answer for this. So we only add like this area. It's not a lot. Let's redo this. I just put it aside so I can remember that. So use a store name attribute and we call it new index. Put it here and we plug the original index in this, set this to be integer, and we just plug this here. And then let's use math and set it to be divide, and the number we want to divide is the step that we go, which is like 1, 2, 3. So now we set it to be 3 first. Can get this number like 0, 0, 0, 1, 1, 1, 2, 2, 2, 3, 3, 3. That's what we want. It's maybe better we use another math and set this to be floor over here. It will look the same. That's because we set this to be integer, so make it become integer. But if we put the flow here, more proper, so let's do it like that. So now we got the number that we want. That is, we got this number, the number for each step. We frame this, and then we need to get this number like a 1, 2, 3, 1, 2, 3, 1, 2, 3. So let's use another math and plug the index and set this to be module. We use this integer, which is the step, and let's plug this to here to see it. So it's like a 0, 1, 2, 0, 1, 2, 0, 1, 2, which is 0, 1, 2, 0, 1, 2. So that's correct. That's what we want. But actually what we want is multiply this by 10. And the 10, it means each round the new point have 10. So multiply this to be 10 first. Let's add these two together. Okay, this number is like a 0, 10, 20. So it's correct, and the second round is 1, 11, 21 is correct, and the third, and the fourth, fifth, sixth is all correct. Just by doing this, we get our number. We have this 10 need to be swapped by point count, which is the same as this. That's how when we change the number of the point. So let's store this attribute and set this to be point count, and set this to be integer, and use a domain size and put it here, right here. So also use a named attribute, get this number for the point count, and that's friend here. Okay, now what else we need? Change number, which is this integer. It's for the step. Now we use arrow to control the step, right? But actually controlled by each loop. So now let's use friend first, but actually that is not the correct way to do it. You will see later. And now let's go to the display curve. We want to make this new index to here, and we use that to draw our curve. Let's take a look at, we have this index to drive set position, but now instead we use a name attribute new index to drive that. We can try to plug this, but it doesn't really work. First we have to sample this. We have to sample this new index by the old index. And after we sample that, we use this to drive this. So now the line behave is very different. It's almost correct if we see it like this, but then now it's all connected together because we only use one curve to do that. So now we have to instancing the curve from each origin point. Let's do that. So use instancing a point and use a point count. It's the same as this. So name attribute and integer and use point count, and let's sample this. And let's put it here, and we can plug this, use this line to be the instance, and plug this over here. Let's use a real-life instance, plug it here, and it will go back to where it looks because of the resample count. So if we set it to be 3, which is the same as the step, it will become correct, so we get what we want. Now we have to get this step, and we can try to do it the same as here. Use the same time, plug with the friend first. Okay, now let's try to play the timeline. It seems to be kind of correct, but it's a little bit off. If we just play the timeline, it will be correct, but when we stop, right, we miss something. The frame time and the loop time actually is not exactly the same. We have to get the correct loop time, not just using frame. Let's get that. So use a stored name attribute and set it to be integer and name these steps. Then let's use a named attribute, set it to be integer step, and we plug this to itself, and we use a map and set it to be at 1. So each step it will add 1. So let's go like a 3 step, because each route we have 10 points, right? So you will see this is the first step, and this is the second step, and this is the third step. Each round this number grow 1, but actually what we want is only the biggest number. We can try to use an attribute static and this to here, and we take this and we give a max to here. Let's see. Yeah, so now it all become like the largest number that will do. So let's try to change all this to be steps. So use a name attribute and the integer and take the steps here. And also in the display curve that we use this name attribute to sample index, integer, index. We sample this value to the resample count of the curve. And now let's try to play the timeline. We got this curve perfect now, even we stop. Okay, so now let's clean this a little bit. You can delete something that we don't need. So now we have cleaned up. Here's the math that we rearrange all the index, and this is we get the steps count, and here is we get the point count, and we use some of the attribute to show our curve. Now we can play noise, make it more twist, and then we just go to the display curve to mesh, curve circle this, and we show it. So now we have this as a curve and also our point. If you like, you can join them together. And then let's just talk about some of the cool technique we can play with this. So now we have our curve all set up. Let's go to the noise. So this is driven by noise texture, organic random, but you can use the void noise texture to get a totally different behavior. So let's try to set this to be 4D and maybe like a F2, and we can drag all this number here as well, change some of the number. By using different texture, we can get a totally different behavior. Now you can play around with different texture. Actually, there's a lot of different texture over here that you can try it out. And furthermore, we can mix these two, set this to be color. So now it looks like a kinda in the middle, and we can even drag this during the process. Start with this noise texture. It looks more organic, and we turn this to be void noise texture in the middle. So like this, slowly turn it to be different texture. Or in the middle. You can set a timeline for this. Okay, so let's set this to be here first. Now let's talk about other stuff. Another trick that is important. Now we have all these points. They begin with center. What if we wanted to be grow on the mesh instead of the center? So let's use the Susam. Let's say if we wanted to grow on the Susam, subdivide a little bit, drag this Susam in here, set it to be relative. We turn it to be point, dash to point. Try this. And also we can use a point vector. Now let's try to play this. It didn't look like what I expect. So why is that? We need to send this position into this position first. So let's use vector math and add, and we use position. So now the position means position of this, because when we plug in, it goes to here. And let's play this again. So now we have this Susam, but it's like exploding. That's because this position is being adding in each steps. That is not what we want. We only want it to be at first. We will have this position, and after the first frame, we don't need this position anymore. We just getting the position from here, and we grow it from there. We use a switch and to vector. And so try to get this and use sim time and compare. So let's see. Yes, that's what we want. It means after the first frame, it goes to true. So it goes to 0. In the first frame, it will add position from here. Take a look about this. It's expanding pretty fast, so maybe grow gap to smaller, see better. So it's working. It grows on this point. And now let's try not to use Susam. Instead, we use something even simpler. We use a grill, and we can see it grow from the point of this grill. Get it to be 30. We see this. It looks very random. We can improve something about that. That is because of this W. Now we don't quite need this. Now it looks pretty organic. It's kind of like improve. I think a lot of people will like this result, and we can make it tighter and smaller. Why now we don't want to use this W? That is because before grow it all from one point, they all set to origin like a 0, 0, 0. They don't have the position information to give variant their noise. So that's why we need to use the index as the W to give a variant of the point. But now we use from the grill. Grill, they looks like this. They have the different location in the noise field, so they will grow differently. Even we don't plug this W, it will looks much smoother. As the same as the Susam. If we just grow it like this, it will looks much smoother. So with this grill that we can do a lot about it, we can make it to be like a matrix, and we can grow the hair from there. So we use a line, mesh line, use an instancing on point, and we plug this line as the point, mesh to point, okay, and use this grill. Let's see. So yes, okay, now we have this matrix, real-life instancing. Now we grow this. Our matrix looks pretty beautiful. Okay, that is that. So maybe we can frame this and frame this as well. Position for the first frame. Okay, so what else we can talk about? And now we talk about how to work perfect on a mesh. So now we use this Susan, grow this hair on the Susan. What if we wanted to work on the Susan? Now let's make a warp modifier in the geometry node. We use a set position and use a geometry node proximity. We take this Susan, set it to relative to the target, and we just plug the distance to the distance point. That is how warp modifier usually will looks like. It's kind of like this. If you have some experience with warp modifier, something will looks like this. But now if we try to play again, the whole thing is like a perfectly warped by the Susan. You can see you can have something like this. That is the warp. However, there's another trick that we can do it without this. So if we turn off this, so now let's try to use the warp modifier on top of this master point. Use warp modifier and pick the Susan. So now let's play again. It still works perfectly, but that is not usually looks like that. Usually it will looks like a lot of straight line. But in this loop or buffer tricks, this modifier actually also being looped. It's behaved totally different than before. The hair is growing from tiny bit and to the longest. It will warp each step, so it will still be very precise. Actually, all this modifier, it works kind of like that, but you just have to use carefully. If you use like a subdivision modifier, it will be a little bit dangerous because each step you subdivide one time, 3 times, your computer will crash. So be careful of the modifier you pick. We have some very interesting potential. The future video I will talk about this more. Now we turn off this. I'm just showing you can use modifier as well, but I prefer use in the geometry node, so maybe we can have some more control if we like to play around with this. So now you can import whatever model you want into Blender and drag into the geometry node. You just put it here, and you can make it to be like this, and then you can render that. And how to render I already talked about in the previous video. You can go watch that. So I hope you enjoyed these 2 videos talk about how to grow curve and point using the loop function. I will see you in my future video. As always, the project will be on my Patreon. Hope you join that, and see you. Bye bye.